Here we're going to talk about our Finley Cemetery scan using ground penetrating radar. So we got access to a map from the Sheriff's Department, and they have an area of interest. It looks like we got some marked graves and then a possible John Doe that is labeled on the map. So we wanted to try to figure out how many people were buried between two marked graves. So it looks like the evidence was that they were in a row. So that is encouraging. And so we were able to go out and scan it, and we're going to look at the actual post-processing of what we found. So we are looking at a GPR scan that was done at Finley Cemetery. That's located in Harrison County here. I've got my ArcGIS, ArcPro pulled up here. So it's off 53 north of the interstate. We're heading west of 49. So we'll zoom in here and find it. So it's right off County Road. So we let that load County Farm Road here. So Highway 53 and County Farm Road here should be located right up here. Those we're coming in here for just our point of reference. So there's County Farm Road, there's Highway 53, Finley Cemetery Road coming in here. Our area of interest is currently right here. As you can reference the report specifically for this, we're just going to show you how the GPR, how the GPR data were analyzed. So looking at ScreeningEagle is the software that we like to use. So we load that up there. I'm just going to reload this whole thing as we're running it. So we're bringing up the baseline survey, which is the first survey that we did. And so that this is a little easy to understand, I like to show you the raw data in this corner and then our gain on the other corner here, some of the processing that we do. So when we come in here, we can do our positioning. So our positioning here is set off. We've got all of ours, our 10 scans that we ran here just in sequence. They were all at 0.3 meters apart so that we can build our 3D model of the area. So you can see that some parts of the returns are stronger than others, even on this image here. I just got a nice little rainbow color here so that you can see the differences. We're running our auto gain, so we removed our wobble. That's the tilt of the antenna as it moves along. We can ground zero it from the antenna that we've got. So we're going to remove the noise that's on the top in our time zero. We can trim as necessary. We do a bandpass filter. And for locating in turn bodies, especially caskets and cemeteries, I find somewhere between the 225 megahertz to the 550. You'll see that we're actually getting a wide range of returns in our megahertz scan. Even though we've got a 400 megahertz antenna that we're using, it still gives us, I think, from 50 all the way up to like 1500. A lot of that's noise, so all of our RF frequencies and even FM radio, cell phones, all that sort of stuff can be picked up as noise trace. So we try to focus it in there. So around the 220 to about the 225 to about the 400 range, really. I usually try to find where our signal is, and I can do that by scanning through all of our different signals. So we're actually picking up some noise on the high end here, but we're targeting this particular area so that we can see our what we're looking for. So that's our bandpass filter. We're going to do a gain, and since we only did a short area, this is really just 4 plots that we're doing on the first scan here. The other one's larger. I'm just going to do my gain as an average of all of them. So this is going to give me my soil type, so we shouldn't have any soil type shifts there. When I run my slicing, I'm going to do my search radius down to 0.3 meters, and that's going to allow us, so when we're looking at depth, we can scan down at depth over these areas, and you can see the amorphic objects appearing here. But I'll explain those in just a second. So let's go back to scan one. So what we did with our run, we ran very close to the back of the first line there, and then we continued, more importantly, past where we thought the grave sites were. So these should be open areas. So when we're dealing our GPR, we want to make sure that we see things, and then we also want to not see things. So we don't want just total noise there. So we can see on band 1, we're already picking up some signal here. That's what these guys are located. I'll move over just a couple so you can see as we move through our different scan lines. This is 1, 2, 3, 4, 5, 6, all the way to 10. You can see this one right here, which happens to be our John Doe that we're looking for, has a really tall scan. Then it starts to fall apart about 7, 8, or 9. And so that is good because we're actually leaving the image there. So we can find this scan by getting to the right height there. So we're looking at our John Doe scan is right here. And I can show you that by coming back to our scans where we've got our good signal. So here's a good signal there. We double click on that and you can see that it's targeting that particular one right there. So we're watching that's the burial of 10, excuse me, our John Doe right there, second one. Now we've got another burial site here coming off the side, but I'll show you how we calibrate this. So to calibrate for depth, we highlight this and then we drop in our hyperbole here. Now the signals are coming in triplets, so the object that we're actually seeing is the one in the middle. Now, depending on the black-white color signal, these can be black or it can be white. And so I've got my hyperbola matched very well to this one already. So I'm going to hit done there, and it's going to hit my calibration. So we're looking at the top of our target, which is our wave triplet here. So our target's going to be right about there. It looks like we're about 0.8 to 0.9 meters down as the top of that particular casket. Row 4 has actually got us a pretty decent sequence there. So we've got 4 burials that we're looking at. Some of them are strong, some of them are not so strong. So we're coming off the one here, and that one should be Lanta Richards. So we're seeing the side of Lanta Richards. Then we've got a burial here. Then we've got a burial here. We've got one here. And you can see up top where we're showing where that's located. And then our last one that we're getting in our sequence is located right over here. So let me just scan through these guys, and you can see where they show up stronger in some areas than others. So here's where the other burial's starting to show up nicely here. It's a weak signal, so that one's probably being collapsed a little bit more, or it might be a coffin burial that's a wooden coffin sort of thing. So we're running them down through here at the very end. But the one that we're interested in is this one. Turns out to be a very strong signal, even in our raw data. So if we shift over and look at our raw data, this is what we're working with. And so you can see as we're getting our returns there, they're kind of hard to see. So when we're running the gain in there, we're amplifying certain areas. Just makes it a lot easier for us to see. So we line up 4 there and we line up 4 there. Okay. So that's functionally what we're looking at. And we can see that this is our target. The other thing that we had here is we can go back to our workspace here. So we also have a GPS scan that we ran on the Finley project. So this one is off GPS. I've got a different color scheme here, but we can set our processing up here, drop our slice down instead of 75. We want to drop it to 3 because those are the passes that we did. This one, some of our GPS signal picked up a little bit differently here, and so we lost our GPS signal here. So this one's just doing a different scan technique as we run through, but we can still see what we're doing. So this one starts at 21, so we're starting to look at some different guys here. So if we look at this one, we can set our hyperbolas here, and I'm going to set my value. I just got a different color screen there. This is looking again at our John Doe target. You can see as we're calibrating, we get our John Doe calibration. Now height, again, just under a meter down is where we're hitting the top of our target in this particular color scheme. So this is on number 23, and I can show you 23 over here in the raw data. And again, faint here, that's really what we're trying to amplify. So we've got 1, 2. So this particular scan we ran all the way over, and we're showing all of the 10 of the locations. So you can see some of these guys are coming in very strongly, and this is what the returns look like, various levels. So there's part of a scan right there, but they're very evenly spaced out, in my opinion, as we flagged each one of the peaks out in the field. But this is the post-process data, so that we can confirm what we were seeing out in the field. I don't like to rely solely upon the location out there. So this one actually has our aerial imagery, so you can see where our location is physically. So there's the Finley Cemetery, and we're coming back and we can see Highway 53 and then County Farm Road. Okay, so if you have any questions specifically about this, we can obviously pull up these more specifically and discuss them further. But that's just an overview of how we're doing it. And again, I'm running our position processing from a GPS here, and then we are running our same processing schedules there, including our bandpass filters, trying to get some of the background noise out of there. But we're looking at these top arcs located there, so that should cover us pretty well. Please refer back to the report for more specifics. So after the scan, we were able to drop orange flags for where we think the John Doe is. That's the strong signal that we had. And we marked all 10 locations of the unmarked graves in between the two known marked graves, and we're able to corroborate with the map itself. So we believe the John Doe is located as the second location over, right there next to the other side of the Lee headstone there shown on the image.